Uh, Hi everyone, this is a new video regarding the recent updates in the Dronacharya mode. What have changed and what new things we have added? I'll just show you a demo, and while demonstrating, I will also tell you about how good it is. So for that, there are existing sessions which is going on, but let's start a new session with a new subject. So let's say I want to learn about computer architecture. uh, let's keep Claude Sonnet as our default model, and let's start from the beginning. And now the AI is planning the course, and it will be done in an interactive manner. So now either you can just read through the steps, uh, and then just continue and go to the next snippet, which can be a question, content, coding exercise, or whatever can be. Anything can be there. But we can also turn the interactive mode. So I will turn on the interactive mode, and let's see how it goes.
Welcome. Let's start with a surprising fact. Before it meant a machine, computer meant a person. In the 1700s, 1900s, rooms full of human computers calculated logarithm tables, astronomical charts, and rocket trajectories by hand, passing partial results to each other like an assembly line. Famous examples: Katherine Johnson, Dorothy Vaughan, and Mary Jackson, who computed orbital mechanics for NASA's Mercury and Apollo missions, as told in Hidden Figures. The electronic machines we call computers today were named after these human calculators. They were built to do the same job, just faster and without fatigue.
Great. So I think this is just a basic introduction. Let's move forward to the next part.
During World War II, women like Katherine Johnson, Dorothy Vaughan, and Mary Jackson worked as human computers at NASA's predecessor, NASA. What were they calculating?
So as we have seen in the previous step, it has taught us concept, and now it has asked us a multiple choice question. So it was this option, because that what I remember from the last step. So let's see. And I guess it should be a correct answer. So yeah, we can see this is a correct answer. Let's move forward.
Now let's get to the actual machine. Every calculation a computer performs comes down to tiny silicon switches turning on and off. So we need to understand electricity first. Atoms have a nucleus, protons, positive, surrounded by electrons, negative. In metals like copper, outer electrons are loosely bound and can be pushed from atom to atom. That flow is electric current. Think of a pipe already full of marbles. Push one in and one pops out the other end almost instantly.
Cool. So before starting computer architecture, it is teaching us something about the chemistry of the atoms and different materials like silicon, copper, different elements which will be used to make the computers, I think, and the chips. So I think this is good to go. What I want to show you is, I think it is an interactive mode, but for that I am like waiting for a good concept so that I can cover it.
The push that drives electrons through a wire is a difference in electric potential, called voltage. It maps neatly onto water in a pipe. Electricity, water. Voltage, V. Water pressure. Current, A. Flow rate, resistance, Q. Pipe narrowness. A tall tank of water, high pressure, sharp voltage, pushes water faster, more current, unless the pipe is very narrow, high resistance, which cuts the flow.
Cool. So now let's demonstrate the interactive mode. And now think of in this way. This course is the course of computer architecture has been divided in a small snippets so that user can understand it, and the content is very easy to follow. But let's say if we have a doubt, so what will happen? Who will answer the question? Who can help us? So for that, we have created the interactive mode. So we can just click on this discuss option, and it will open a ask Dronacharya mode, and in this tab we can basically discuss with Dronacharya about the concepts. So let me ask a simple question. I didn't get what is voltage. Can you please explain me what voltage is in easy words? And see, it is running, it is thinking, it will answer.
Sure. Voltage is just a push. The difference in electric potential that makes electrons want to move through a wire. Like how pressure in a water tank pushes water through a pipe. No pressure, no push, no water flow, no voltage, no electron flow, no current.
Alright, so as you can see, if you have any doubt on a particular step, you can just turn on the interactive mode, and it can converse with you. It can also explain you the concept in more easy way, and you can ask it as many times as you want, because it is your Dronacharya and it is not judging you. So you can just ask it multiple times, it will explain you, and your concept will be much clear. Now let's say if I ask something off topic. Can you write the code for palindrome? So it is a very off topic question. Let's see what it does.
That's a bit outside what we're covering here. This lesson is about electricity, voltage, and computer architecture basics, not programming exercises. Let's stay focused on the voltage current resistance analogy for now. Does that water pipe comparison make sense?
So as you have seen, we have a strong guardrail around the Dronacharya mode, so it will never divert, and it is strongly aligned with the concept you are understanding. Now let me ask a question which is in the future, but it is still related to computer architecture. So what is a NAND gate? Can you make me understand, and how it is used in architecture of computers?
Great question. But NAND gates are a topic we haven't reached yet. That comes later when we cover logic gates, building on binary and transistors. For now, let's stick with voltage, current, and resistance and the water pipe analogy. Does that comparison make sense so far?
So as you have seen, it has told us it is coming in a later section. So sometime what happens, we ask question to our tutor on a certain topic which is not yet taught, and the way our teacher tells us, like, it will come in the future, let's focus on the current existing topic. The same way Dronacharya mode is created in an interactive mode. It will never divert, it will always keep you on the track and not let you divert, so that you can get a better understanding. Yeah, I think that's a short demonstration of the capabilities we are building on. It is still in beta. We will soon push it to the production, and you all can be able to use it. Thanks a lot for watching.